Yeah, so I'm going to be taking up how to solve or approach matrix match based questions in JEE Advanced papers. Especially in the first paper, there are four matrix match questions, which with lists given, list one, list two, and options are there. So particularly when options are given, what is going to be the easiest way of approaching the questions quickly in the given span of time? Yeah, as such, JEE advanced papers require you to manage time very well in a very prudent manner. So how to minimize the time of approaching matching questions when options are given. So let's quickly have a look at the questions. You see how quickly we can solve the questions of matrix match if you know particularly how to approach when options are particularly given. So let me quickly share the questions on the screen, and without any further delay, let's get started. Right. So here, this is the first matrix match question, which is 15th one in the serial order of the paper. So this is a question which involves finding torque, magnetic field and all given. So the natural tendency to think is using torque equal to m vector cross b vector, where m is the magnetic dipole moment. So my suggestion would be to look for options first and identify from the options if you have a case where any one particular from you pick, say from list one, the first one you pick. No, the first one, if you pick, you look at the options, you have two places where q is there, right? So then I would suggest just for a moment you leave that. Then you look at the second one, there are two places where p is there. Then third one, you see there are two places where s is there, and in the fourth one you see there are two places where r is there. So every option in list one is matching. If you look at the options a, b, c and d, there is no place where unique match is happening for any particular option. So let me just quickly glance if there is any other question where uniquely there is a match. Now if you look at this, there is no unique match. There are two places where s repeats. Second one, two places where t repeats. Third one, two places where p repeats. And fourth one, of course, you have multiple times s and r repeating. So that is not the one which we would be looking for. Now in this list, you see first one, very nice. In the first one itself, t, s, p and q, all four different things. Is there any other one like that? You just identify that also. No, second one, you see there is r, p, r, r. So r is involved multiple times. Third one, t and s involved multiple times. Fourth one, q involved multiple times. So if you just crack the first one, so you take the first statement and if you crack that, then there is no need for you to worry about second, third and fourth. So let's straight away delve into solving this particular question. So list one says you have 10 power minus 3 kilogram of water at 100 degrees Celsius converted to steam. At the same temperature, pressure is 10 power 5 Pascal. So what would be done over here is you take the value of, from first law, you can say that Q will be equal to delta U plus W. Now, if you are going to make use of first law, see the question involves possible changes in internal energy of the system. So essentially we need to find out delta U value. And for finding delta U, we are going to make the use of first law of thermodynamics, because clearly here there is a phase change, water converting to steam. So we cannot think of using any ideal gas equation, any particular process, nothing of that sort would directly work. So we'll directly take first law and we'll try to figure out what is going to be delta U. If we find out Q value, see I'm separately finding it out. Q value is going to be m times latent heat. Now mass is given to be 10 power minus 3 kilogram of water into latent heat value is 2250 kilojoules per kilogram. So that is anyway in kilojoules, options are there. So let me directly calculate. This would be in kilojoules. So we are going to get 2.225 kilojoules. So that is going to be Q value. Next, since here the system is open to atmosphere, 10 power 5 Pascal atmospheric pressure, here the pressure is constant. So you can treat work done as P times delta V. That would be work done in the particular process. So this work done is going to be, let's say 10 power 5 Pascals is pressure which is given. So 10 power 5 into now delta V. You see they have said that when heating happens, the volume changes from 10 power minus 6 to 10 power minus 3. So I will find out the volume change delta V, which is going to be like 10 power minus 3 minus of 10 power minus 6. But this would give answer in joules. Later we'll convert it to kilojoules. Now, if you observe 10 power minus 3 minus 10 power minus 6, 10 power minus 6 is so small in comparison to 10 power minus 3. So we'll just simply ignore this 10 power minus 6 and do the calculation. So this will be 10 power 5 times 10 power minus 3, which would be like 10 power 2 joules, or it is going to be like 0.0, sorry, not 0.0, 0.1 kilojoules. No, we know Q value, we know W value. Q is like 2.225 minus W is going to give delta U. So delta U is going to be 2.125 kilojoules. So from the options now, if you're going to match it, and also see the question says, or either it should exactly match or it should be a close approximation. So this delta U is very close to 2 kilojoules. So the answer for first one must be P. So now you see C is the only option where you have one matching with P. That's it. You're done with it. Now, for me to explain all these things, it is taking this much time. But when in a test scenario, there is no need for me to there is no need for me to explain anything. I would just be solving the question. If you solve the first question, it should not be taking you more than 2 minutes for sure. You just find out Q, find out W, and subtract and get delta U. That's it, and mark the option. Now let's see if there is the last matrix match. Is there a case where there is a unique option? So first one ruled out because there are two cases where P is involved. Second one RPTS. Wow, second one is involving all unique. Third one QTRQ. So 2 times Q is involved. Fourth time TSQ and R. So in fourth one also you have unique. So either you solve second or you solve fourth, you are done with it. Now why I'm asking you to identify both the ones where identify all the ones where unique options are there, so that now you can decide whether you want to solve the second case or you want to solve the fourth case. Either one of these two you solve, you are done with it. Right now, second and fourth, let me go based on my comfortability level. So you could look at the system, and then based on whatever is your comfortability level, you can either choose between second one or the fourth one. Right, so what I'm going to do is I'm going to do the second one because that is appearing first in the serial order. That's all. So I'm going to do the second one, but there is no big difference in this case between second and fourth. So essentially you need to find out the final image formation. So let's take the second one, apply lens formula twice. So when I'm going to take the first time lens formula application, I'm doing the second scenario and I'm going to apply for the first lens. So let me write like this. For the first lens, if I'm going to apply 1 by F, so 1 by 10, that is going to be 1 by V1 minus 1 by U value will be minus 20. So I'm going to have 1 by V1 equal to 1 by 10 minus 1 by 20. From here, I solve and get V1 equal to 20. So V1 is the position of the first image that will act as object for the second lens. Now, since V1 turned out to be plus 20, the object distance for the second lens will become plus 15. So now for the second lens, I'm going to apply. So 1 by F minus 10 equal to 1 by final image V2 minus 1 by U value is going to be plus 20. Sorry, not plus 20, plus 15. Now here I'll have to be very careful. So plus 15 is going to be the value of U for the second lens. That is because 20 was the distance from the first lens image formation. That is going to act as object. So it will be 15 plus 15 for the second scenario. Now find out V2 from this. So 1 by V2, this would be 1 by 15 minus 1 by 10. So LCM, if I'm going to take 30, it is going to be 2 minus 3. So V2 is minus 30. So V2 is minus 30 means final image is going to be to the left 30 centimeter distance. So second one is going to simply match with R. Now I'll just go second one wherever R is there, first option, and that is going to be the answer. That's it, done with it. Right? But when you're working like this, you'll just have to be very careful. Slowly work. It should not, since I'm explaining, it takes some time. But otherwise, when you are working on the question, you just slowly work on that particular question. It should not take you more than 2 to 3 minutes for solving this question. In fact, this is like just a JEE main level question or a NEET question where they can ask simple application of lens formula. The previous one also is a similar thing only. So now the issue will come. See, if suppose say you are not given the options, then this becomes like a set of 4 different numerical questions. That is going to be like definitely time consuming. The options are not there. They gave you a matrix match with no options. You have to solve and figure out first one matches with what all cases, second one matches with what all cases. So that becomes like then 4 individual questions, which is going to be time consuming. But when you have options available, just go through the options once and try to pick those questions first where unique option match is happening. That will save quite a lot of time and you will be able to solve that particular question easily. Now let me go to the next set of question which I would have actually attempted in the paper. I'll just share it, hold on. So yeah, now let us look at this particular matrix match. Now here there are no options where uniquely it is happening. So let's go based on comfortability level. Let's see the question first. Here they are saying list 1 describes 4 systems, where first one is like kind of something circular motion, second one is projectile motion, third one is SHM, fourth one. And so here again, fourth one is like some circular motion and all happening, object is like thrown up. So combination, 2 particles are moving. You have to find out the relative velocity in the cases. Now, which one am I going to pick for doing this? So I'll go based on whichever is easy for me from this list and I'll solve that first. So if you look at the first one, you need to find out relative velocity in the 2 cases. 2 cases as in you have to find the relative velocity between the 2 particles. So if I take the first case or the first statement, here these objects are executing uniform circular motion. So velocity of A and B direction only will keep on changing, but their magnitudes are going to be same throughout. And since A and B are both moving uniformly with the same angular speed, at any point in time, the separation between A and B will always be the same. That separation will never change. So the magnitude of relative velocity is not going to change at all with time in the first case. And that is because when A would have come over here, let's say, in the same time B would have reached somewhere over there, the angle between A and B, which subtends at the center, that will always remain 90 degrees, and also the separation between A and B will also be the same. It is not going to change at all. So I would pick the first one and find out what is the initial relative velocity. I don't have to really worry about what time you are asked to find relative velocity. In fact, the question requires you to find that t equal to pi by 3. In the first one, the time does not really matter. At any time, the magnitude of relative velocity is just going to be the same. So initial relative velocity, I'll just find out. So VA value is going to be R omega, since it's a circular motion. So velocity of A, let me just use a different color. So velocity of A is going to be 1 meter per second. Velocity of B is also 1 meter per second. So just find out the relative velocity. So V relative, this is going to be root 2. So now you see which option is going to be root 2 for the first one. So root 2 means S. So S being the situation. Now for the first one, where do we have S happening? So either B or C. First one is S. Now you see if there is an option where unique answers are there. So you see second one PT, they are different. Now fourth one RR, so I'll just leave fourth one. I'm not going to be worried about fourth one at all. So either you solve second one or you solve the third one, because now second and third out of B and C, now second and third, they are having different options. So either you solve second one or you solve third one. Now if I just observe, Second one is a projectile motion question. Third one is going to be a SHM based question where you need to find relative velocity at some particular time. So I would go and pick the third one because I just need to be concerned about finding out like VA using differentiation, find VB using differentiation, put the respective time and solve. In fact, if I do that, they have given x naught to be 1 and t naught to be 1. So when I'm going to find out VA, that is going to be like x naught by t naught. I'm just differentiating. VA is x naught by t naught. Sine differentiation becomes cos of t divided by t naught. And VB, that is x naught cos function. So here you just look at it, this sine of t by t naught plus pi by 2 will become cos. And when I differentiate it, I'm going to be getting like x naught by t naught. Cos differentiation will become minus sine t by t naught. Now find out what is going to be the relative velocity. X naught value is given, t naught value is given. They're all nicely given to be 1. So if I find out VB value, my VB value is going to turn out to be at t equal to pi by 3. So at that instant, you need to find out. So VB will be minus of root 3 by 2. And VA is going to be half. And that is because x naught and t naught values are given. You can substitute for them, and t also is pi by 3, substitute in the two respective equations. Find out VA and VB. Now you need to find out just their relative velocity magnitude, right? So VA minus VB you need. So VA minus VB modulus of that, VA minus VB, the modulus is going to be root 3 plus 1 by 2. That would match with P. So when that is matching with P, I'll go ahead and pick it. So third one should match with P. So C is the answer because I solved for SHM one, third one. Third one is matching with P, and answer should be C for this particular question. Then now let's move on to the next matrix match over here. Now, how I would approach this particular matrix match. In fact, this is a question in the paper where if you did not identify correctly how to approach it, this question could take away a lot of time. Maybe you could spend somewhere around 10-15 minutes. You might get the answer because it's not like a very tough question and all that, but it is a good concept based question only. But then it could take away quite a lot of time if you're not picking the right approach during the test. Now, what I would suggest for this one, in fact, there are no cases where unique one option only exists anywhere. Now, what I'll do is, now look at the list values. So when you see list 1 and list 2 values, so options in list 2 are like this. So which means there is one place where 0 is there. Now you try to identify that particular one from list 1 for which the answer could possibly be 0. You try to read the situation, what they have given in the question, this particular situation, and then you try to identify for which case 0 would be the answer. Now why is 0? Because 0 means some vectors and all are involved. So something like perpendicular vectors, dot product, cross product, something on those lines. So you can try to identify in which case the answer is going to become 0. Once you identify that where the answer is going to become 0, then you go and look at the match options, ABCD options, and then try to solve the question. So let us try to figure out in which case you're going to get 0 as the answer. Essentially, this is a case where you read the statement and all that. I hope the statement and all you must have already read. I'm just giving you the approach. How should you be solving this? Essentially, you are asked to find the torque on this particular small ring, that circular loop. You have to find the torque. List 2 basically gives the torque. So you need to find out the torque values. What I'm going to do is I'm going to first find the area vector of that particular small loop, in which direction that area vector is pointing. Now that area vector is pointing along k cap, so I'll write it as a times k cap. That is the area vector of the small loop which is present, and that loop is held fixed only. So area vector of the loop is not going to change. It is a solenoid that is rotated, and flux is going to be changing associated with the loop depending on the situation. Now, magnetic field created by this solenoid is going to be along the n cap direction. So this magnetic field in vector form, I'll write it. This is going to be mu naught mi by mu naught mi. It's an infinite long solenoid, so mu naught mi n cap. That is going to be the magnetic field. And flux through the loop will be dot product of b vector and a vector. Now you identify in which case the flux possibly is not changing at all. Why am I talking about flux not changing? When flux is not changing, there won't be any induced EMF. Flux not changing with time, there won't be any induced EMF in that particular ring. If there is no induced EMF, then there won't be any current. So it will not be like a current carrying loop. That will not behave like a magnetic dipole. So if that is not a magnetic dipole, then there is no question of torque acting on that particular current carrying loop. So we'll try to figure out in which of the options flux is not going to change with time. And it is dot product of b vector with a vector. Note that a vector is pointing along k cap and b vector n cap is what is given in list 1. So you just look for the case where the dot product of n and k is going to become 0. Either 0 or it does not change with time. Either one of the possibilities could be there, where n cap dot k cap, if it is not time varying, in such cases the flux is going to be a constant. And you will identify that in case 2, the flux is going to be 0 itself. The flux itself would be 0. It is not changing with time, but flux at every instant of time remains 0. So there is no flux change. There won't be any induced EMF. So it is going to be case 2 where answer should be matching with P. Now go to the options. See where second case you have P. So second case P is there in 2 of these things. Then you identify, see in 1 you have QQ, so there is no point in solving that. Third is SS, so it is only the fourth one that you need to be solving for. Now after identifying that it is the fourth one that you need to be solving for to mark the answer, now for the fourth one, so that is this case you need to be solving for. In that case also you look at the options, it is T versus R, so you have to decide whether it is T or R. Now look at the list R and T values. So in R, it is saying that torque is pointing along I cap direction. In T, it is saying that the torque is pointing along negative I direction. So I don't have to really go about finding the torque. I just need to find the direction of torque to identify the correct answer. That's it. Now, direction of torque, whether it is I cap or minus I cap, that is going to depend upon what is going to be the direction of M vector. So you see this particular loop, this is present in a region where this solenoid is rotating and n cap is going to be pointing somewhere like that. N cap meaning this is going to be the direction of external field, because external field is going to be in the direction of n cap. And this cross M vector should be pointing in the I cap direction. And that is what we need, right? So you identify the case where M cross B is going to be pointing along either I cap or minus I cap. So that is what you need to be seeing for the fourth one. So if I'm going to be taking the case, let's say we go like this. Look at the fourth one. So it is cos omega t j cap plus sin omega t k cap. That is how n cap is changing. And note that this rotation is happening in the YZ plane. So you need to carefully solve. This is one question where solving for one option also is going to be time consuming. And luckily we said that second one is P, but certainly we need to solve for the fourth case. Now without solving for the fourth case, now just imagine if you have to solve for all the 4 cases one by one, how much of time it is going to take. So this certainly is going to be tough in terms of time consumption. So it is just that you need to do the fourth one. Right? So this fourth one, n cap, we are having 1 by root 2 cos omega t j cap plus sin omega t k cap. So j k rotation. So just I would want you to observe that if we take y axis and z axis, and n cap would be pointing somewhere over here like this, where this angle is going to be omega t. So originally the solenoid would have been along y, and then the axis of the solenoid, I'm talking about that n cap direction, that would have been along y, and rotation happens like this in the fourth case. From n cap we are predicting that. So cos omega t plus sin omega t k cap. So this angle should be omega t. And as time progresses, this n cap is rotating in that sense. Now we need to be figuring out what would be the sense of the induced EMF in this particular case. So for that, let us see what happens to the flux. Is this flux going to increase or decrease? That would be our requirement. Note that area vector is pointing upwards. I'll show that. See, area vector A for the loop is pointing up. So what is happening to the flux? Note that this n cap is rotating towards the area vector. Right? So the flux associated with the loop tends to increase with time. So this flux is an increasing flux, that B dot A. So if that flux is increasing, the induced EMF will be such that it will try to create a magnetic field pointing in the downward direction, thereby trying to reduce the flux. So if the magnetic field is going to be pointing downwards, the current will be induced in the loop in this particular manner, like this, where m vector for the loop would be pointing down. So once you have identified this, that's it, you are done with. Now m cross b you need to figure out. You have to carefully visualize this in 3 dimensions. Now m vector is pointing in minus k cap direction, and this b vector n cap, it is lying in the yz plane. So it's a 3D kind of thing. So this is y, here you have z axis and x axis. Let me mark it like this. So x, y and z are 3 mutually perpendicular axes. N cap is rotating in the yz plane. Now if I want this m vector cross b vector, so m cross b, you do the cross product and see that this m cross b would be pointing along x axis. This direction is what you just need to identify. If you identified this, then you can say that R would be the match for it, because that is the case where m cross b is pointing in the I cap direction, torque. So you can just go about marking the answer. You have identified the direction that should match with R. So match with R in the sense fourth one should match with R, and C should be the answer for this particular question. Now doing this question in the test would have been a really challenge. So you should have been wise if you have attempted this particular paper. Actually in the test itself, you should have been wise whether you take the call, whether you want to do this or not. If there is no other question that clicks, maybe you spend some 5 minutes on this. So I think it should be taking around 5 minutes for you to solve this. Lesser than that, if somebody got it, that's fantastic. Properly they logically somewhat eliminated and got it within 5 minutes time. This question, if they solved, that's really good. Certainly it is time consuming. You need to solve for at least one particular case. Even after you identify that second one is going to match with 0, you need to solve for the fourth one. And fourth one, you can just identify directions, but 5 minutes, see, for me to explain it is taking time. In the paper, it should be taking you 5 minutes to do. But first look at the options. Once you look at the options, the 3 questions that that I discussed before, the rotation of the solenoid rotating question, the other 3 questions, they should be taking roughly say 2 minutes, 2 minutes and 3 minutes, right? Because that's only one you need to solve for in 2 of those questions. One statement you need to solve. That should be done in about 2 to 3 minutes of time. So those 3 questions, you did it in some 10 minutes, let's say, and this one question took some 5 minutes. So in 15 minutes, the matrix match max should have been over in this particular part. You pick the easy questions first, right? So paper 1 is certainly going to be kind of a challenging paper, right? If you got stuck in any one particular area and you spent too much time, that is where things would start falling apart, right? So be careful in picking the question and approaching the question based on your comfortability level. On the spot in the test environment, you need to be making this particular call, right? Okay, so that's about this one.